Good morning. We are getting ready for lesson 8, variability in data distribution. It's not much different than calculating the mean. All we're going to do is take that mean and we're going to look at data and what that means. So the first thing that I need you to do is I need you to calculate the mean, or we can't do any variability. So Robert's planning on moving to New York. I need you to read the scenario and what he's expecting. Then I need you to look at the data. Exercises 1 and 2. Number 1 says calculate the mean for both cities. So it says each city, so I should see New York City mean, and I should see San Francisco mean. And then you need to tell me where is Robert going to want to move based on this scenario, and then give your advice, and then you need to tell me why. You need to do that before we can even talk about variability. Go ahead and pause the video and do that now. Now, when we're talking about variability, we're looking typically at data on a dot plot. We could do histogram, but it's a lot easier to do variability with a dot plot. The first thing that I did was that I did number 3. Mark the location of the mean on each distribution with the balancing triangle symbol. How do the two distributions compare based on their means? So New York, there's my balancing symbol, and San Francisco, here's my balancing symbol. So how do the two distributions compare based on their means? Well, their means are about the same. They're very close. But this is where it's going to get a little bit different when we're talking about variability, because variability talks about the spread of the data. Is the data really clustered around that mean, or is the data really spread out super far from the mean? So it says describe the variability of New York City's monthly temperatures from the New York City mean. So we're looking at New York City. What do we notice? Is it clustered around, which means is it gathered around this balancing triangle symbol, or is it far apart? Well, for New York City, it's spread out. It's spread out. Now we need to describe the variability of San Francisco. Is it spread out or is it clustered? For this one, it is clustered. Now, when we talk about also variability, when it is spread out, we mean that they have a high variability. And I'll talk about in 1 second what that means, which means that the opposite would be that it has a low variability. The second part of variability, other than looking at the graph and being able to say, is it high, is it low, and where that data is, we're also going to be comparing. So we're asking you to compare the variability of the two distributions. Now the mean we know is about the same, but is the variability the same, or is it different? If it's different, which monthly temperature distribution has more variability? When we see the word more variability, we're talking about high variability. So are they the same? Are they different? Let's go back. What we described, they're different. They are because New York City is more spread out with high variability. Now this means that if there is a high variability, that this mean is probably not an accurate representation of the actual middle temperature. When data is clustered, that mean is a pretty accurate description. But remember when I first started talking about mean, I said mean really can't be used if there's a lot of outliers. And in here, there's a lot of low data and there's a lot of high data. So to say that New York City is typically 63 degrees isn't accurate. It won't be accurate all year round. But for San Francisco, yeah, 64 is about what it is all year round. So now it says, if Robert prefers to choose a city where the temperatures vary the least means low variability, which city should he choose? Explain. Go ahead and explain that now. Now we're looking at considering the mean and variability in a data distribution. Same thing what I'm just saying. Is this balancing triangle an accurate representation of the mean, that middle data? So it says, Sabrina asked Robert which city he thinks has the better climate. Well, which one does? Which one has a mean with a better accurate distribution, accurate representation? Go ahead and answer that now. So the second part just has you explain why you picked which climate is better. If you did it already up here, you're good. If you haven't explained why, go ahead and do that now. Exercises 8 through 14 is having you not only plot data, but it's also then asking you to look at the variability. So what you are going to do is you're going to plot the data for morning and afternoon. Here is your data chart. Then you're going to talk about what is the mean for the morning, what's the mean for the afternoon. You're going to talk about which mean gives a more accurate indicator of a typical time. So before you can do this, put your balancing symbol in. So then you know, is the data clustered around that mean or is the data more spread out, which means variability. Then you have another set. This is number 12. It starts up here and then it goes down to here. I just want you to do 8 through 11. I only want you to practice this skill once. You do not need to do number 12. You do not need to do number 13, and you don't need to do number 14. All right, then you have your problem set. I do not want you to do number 3. So you must do number 1, A, B, C, number 2, A, B, and C. I will be checking 8 through 11 before you can grab your exit ticket and move on.